now, so here we go.
Yeah,
okay, no more swearing, guys.
Yeah, no more jokes.
I don't know if it's good or bad that we both just said that word around the same time.
By the way, Sister Lemon actually gave us some kudos on that and said we have a pretty good group and we're doing good. So,
I'm glad to hear that.
That means she actually watches it. We have to take it seriously.
No, she said she has. Yeah. So.
All right, cool. All right, I have the group meeting quiz open and at number 3. So
that's where I'm at.
I got the null hypothesis.
That's what I got as well.
Yes.
Yeah, because it means that it's true.
Yeah.
Mm-hmm. Okay. The p-value of obtained is at least as extreme as the one that was actually observed.
Yes. So
that's not an answer choice.
No, I mean, so I got on the p-value, which hypothesis do you assume to be true? I got the null hypothesis.
That's what I have.
Yes. That's basically the same question as the one before.
Yes.
Okay. So suppose the null hypothesis is u equals 10. Which of the following represents the alternative for a two-tailed test that would be not equal to?
Yes, not equal to. That's what I have.
Okay.
Right, because greater than and less than would be either right or left tailed.
Mm-hmm. Question 6, which of the following represents the alternative hypothesis for a left-tailed test?
HAU is less
than. And
I
got
less than 10.
Right?
Yeah.
Yes?
Yes, that's what I got. Less than 10. Question 7, which of the following represents the alternative hypothesis for a right-tailed test? So it's just the opposite of greater than 10.
Yeah, it's greater than 10.
Number 2.
Or U is greater than 10.
Right,
yeah.
U is, mean.
Yeah, mean,
yeah.
Pardon me.
Yeah. Sorry, guys, I just sent out a text in the group text to Kayla, so
okay.
Your phone's probably just lit up for a minute.
Yeah, that's fine.
Which relationship would result in failing to reject the null hypothesis? If I'm not mistaken, it's less than A?
No, I thought it was Z. I thought it was greater than. P-value is greater than Z.
No, because I know it always has to do with alpha.
Does it?
Yeah, because alpha determines...
okay.
Because based off of alpha, whether it's usually 0.01, 0.1, or 0.05, something like that.
Yeah.
Right.
If the p-value is, I think if p-value or the probability value is greater than alpha, then it has a greater probability that the null hypothesis is true. So I think that the p-value is greater than A. We would fail to reject the null hypothesis.
Okay.
Yeah, that's the thing. That's what screwed me up on the test is reading too fast.
Yeah, I have to talk through everything, and I'm sure, when I took my accounting test, it was 2 hours of me sitting here talking with my hands, and my teacher had to watch the whole thing, and so at the end I apologized. It felt weird to apologize to a computer, but...
Well, okay, so the 0.05, if it's less than 0.05, that means that the null hypothesis is rejected.
Right,
correct?
So if p-value is less than the alpha, then we reject the null hypothesis. Right.
So failing to reject would be our first choice in the multiple choices, because it would be greater.
Question 9. Yeah, that answers question 9 for us in that case.
It's less than, right?
Right.
Yeah, which really would result in rejecting the null hypothesis.
Okay. So an insurance company is reviewing its current policy rates. They're concerned that the true mean is actually higher than the 1,500. So the null is obviously, it equals 1,500. If they're worried about it being higher, then they're thinking that the average claim is greater than.
Greater, yeah.
Okay. Null hypothesis, we just kind of talked about that, is equal to?
Is equal to 1,500, yes.
1,500, yes.
This is like one of the first sections that
Slow down, guys. You're killing me, Smalls.
Oh, sorry. This is one of the first sections that taking extensive notes really helped me out a ton.
Yeah. I'll give you props on the movie reference, Sean.
Actually, I have a shirt my wife bought me. It's got the catcher. You know, it's not what he's saying, but it says "You're killing me, Smalls."
Yeah.
So.
My brother has that shirt, and if he wasn't 12, I would steal it from him.
Yeah. Probably wouldn't fit you, Fred. Okay, so the following on 11 would be that means that the claim would be equal on 11, right?
Yes.
Yes.
Okay, because that's going to validate the null hypothesis, make it true.
Correct.
Okay, so I got to start using the correct terminology. We failed to reject the null hypothesis, correct?
Yes.
Okay. We got Kayla yet?
Nope.
No, still nope.
All right, 12. The insurance company assumes the distribution of sample mean is normal. Is this a good assumption? I put yes.
Yes.
Because the sample size is large.
That's what I put.
Yep.
Mm-hmm.
That works.
Yeah, because we don't automatically know that the population is normal, so we can't just put that.
No, we can't.
So question 13 says, what theorem or law justifies your answer to the previous question?
That would be the central limit theorem.
Limit theorem, yeah.
Mm-hmm.
That's what I have.
And then see this is the one that I switched during the test that I associated distribution with the law of large numbers and the mean placement with the mean being close to the population mean was central. I swapped the two for some odd reason. So
I'm sure I did the same thing.
I didn't, but I probably got the math problems wrong.
Okay. Yeah, but you got a pretty dang good score there.
You know what?
You did better than both Sean and I.
I always was with her and trying to learn, and so when she saw my score, she goes, "That's pretty good."
Mm-hmm. That's what
For
that
you.
perseverance does.
Hey,
That's pretty good for you.
I have been studying hard.
Well, that's Susan. That's proof that your study habits are being successful.
Mm-hmm.
Well, hopefully they'll be good enough in the nursing portion so I can get my bachelor's in nursing.
Well, let's design our study around Susan's study habits.
Yeah.
And being test scores. Okay, so question 14, which of the following is the test statistic as defined in this lesson?
Z?
Yes.
Okay.
Yeah, because X is like the population mean, right? Or that's the distribution of sample means, right?
Yes.
And then S, I don't remember what S is. And N is the sample size, right?
Mm-hmm.
What was S?
Have we had S so far?
We did, but I can't remember what it was.
Okay.
Okay, well.
I'm just curious here.
All right, number 15. What is the Z-score associated with this test? And they give us all the information above. Okay, so standard deviation is 40, but the sample is 36 sales. So we need to divide 40 by 36. And I need to switch that.
Isn't it the...
What are we?
It's the square root of 36.
Oh, right, sorry.
I'm going, wait a minute.
Yeah, 6 is the square root of 36.
Okay.
So with that, I got 6.667, basically.
Yes.
So then we take 6 divided by negative 6 divided by 6.66, and I got negative 0.9.
Yes. Now, don't you have to have 3 places there? Do they want us to have 0.900?
From what I've seen,
that's
if
what
it's
it
just
says.
zeros afterwards, it doesn't matter.
It says round to 3 decimal places.
Yeah, and rounding is valid with or without the zeros at the end. So
I could put 0.9 and be okay?
that's what I'm, well, negative 0.9, but yeah, that's what I'm doing.
Why didn't I have a negative? Ooh.
Because you probably did 150 minus 144 instead of 144 minus 150.
No, I did it the other way, but I messed up. It's me. So you think negative 0.9 will work?
Yes.
Okay.
Hold on here. I love this. I love this calculator, but I just can't read it. So I can put the whole entire equation in there without.
And then to calculate the p-value, what do we do again?
P-value is the probability.
Probability.
Okay, so it's in the applet, right? So
yeah,
that's 0.184.
Yeah.
Okay. I second guess myself sometimes.
You saw good.
Did you do okay, Jared, on the test?
I did all right. I think I did the worst out of our group.
No, I doubt it.
You're putting yourself down, Susan. I heard everyone else was
I need to stop that.
Huh?
I need to stop that.
Yeah, you did great on the test.
Okay, was there a link to the applet anywhere?
There was, and I have my bookmark, so I just pulled it up.
Yeah, there it is.
Oh, was it there? I don't know. Talk about then.
Okay,
Oh,
so sorry guys. I'm a little behind.
No, you're fine.
So okay, so our p-value, are we doing, so is the z-score on this, is that going to be a two-tail probability value on question 16?
No, it's a one-tailed because the alternative is a less than.
Yeah.
So
okay, so we need the left-hand side.
Right, it's pointing to which side it wants.
Because our result was the
really
negative.
Nice.
Yeah.
Because the result was the negative, right?
Exactly.
So 0.1841 is what you guys got, or 184?
Uh-huh.
0.184.
Okay.
0.184.
I definitely need to do more association here with some of these things. So.
All right.
Okay. 17.
And so
what
it says, what inference would you make about the null hypothesis for the problem? I think reject.
We would fail to reject because if
we'd fail to reject because we're
p-value is greater than the alpha.
Right, we're greater than 0.05.
Okay.
Okay, so question 18, what is your conclusion for this problem?
I put we have sufficient evidence that the true population mean is 150. Because from what I remember with stats, and granted this was a while ago, you always base it off of the null hypothesis. So you either say we have sufficient evidence that the null hypothesis is true, or we have insufficient evidence that the null hypothesis is true. So you never use the alternative in the conclusion.
Yeah, because if it would have been less than 0.05, then it would have been the very last one that says we have sufficient evidence that the mean is less than 150.
No, at that point we would say we have insufficient evidence that the true population mean is 150 because you always use the null hypothesis.
Oh, okay, okay.
I could be wrong, but that's what I think I remember reading and what I remember from stats.
Okay, so question 19. There are two types of errors that can be made when performing a hypothesis test. Which one involves rejecting the null hypothesis when the null hypothesis is true?
I put
Type
type
one.
1.
Yeah,
Yes,
I just looked at that before we started.
Yeah. And then 20, a researcher decided that instead of using a level of significance, alpha equals 0.05, he will use alpha equals 0.01. Which of the following will be true? I put the second one.
I know it's not the first one.
Right.
Why isn't it the first one?
I think it would be the first one.
Because he's lowering that, and so he's making it almost impossible to disprove, the unit, right? The null hypothesis.
Some small number so that the probability of committing a type 1 error is low. Okay.
No, that does make sense. That the smaller the level of significance, the higher chance that we have to reject the null hypothesis, or to fail to reject the null hypothesis when we should have.
No, by lowering the level of significance, it raises our chance of rejecting the null hypothesis when we shouldn't have.
Which is a type 2 error.
Okay, I'm confused.
Oh shoot, what's the
we reject it when it's true as a type 1 error, so that's what we just answered in 19.
Yes.
Okay, so rejecting it when it's true, in order to do that, that means that alpha value, the significance value, would have to be higher, correct?
So to reject the null hypothesis, the alpha has to be greater than the p-value.
Right. So we'd have to increase it. Okay.
You're right. I had that backwards about how p and alpha are related again.
Yeah.
Right.
So
okay. So it would be a type 2.
It's a type 2 error.
Yeah.
Yeah.
Sorry, team.
Because you're going to prove that it's true when, let's say your result was 0.04, because your significance now was at 0.01. You're proving an untrue hypothesis. And is that reasoning, how I put it, correct?
Yes.
Okay, so that, I guess that little diatribe there would say that it would be B. Okay, now I understand.
It's not good. We have to walk ourselves through some of this. I had to walk myself through it like that for the homework.
Yeah. You didn't talk like this, did you, Sean?
Me? No.
Yeah.
No.
I talk with my hands now and again too, so. Usually I'm pointing that way. It's not me.
All right.
Okay.
21. If alpha is 0.05, compute the probability of committing a type 1 error. 0.05.
Yes.
Okay. So, don't submit, guys.
Okay, hold on. So why?
We got number 18 wrong.
Number 18 is wrong.
I think it's the third one. I think it's we have insufficient evidence that the true population mean is less than 150. So I could have mixed those up.
Yeah, well,
that would have made sense.
That's why I was asking, because our p-value really wasn't that high. It was only
right. Well, that's what I was saying. Maybe we always use the alternative instead of the null.
So we base off of this. Was that the only one that we had wrong, Sean?
Yeah.
Okay. I'm going to submit with that change.
Now, real quick, just, okay, so our alpha number is, if our probability equals 0.05, that means that, you know, anything below 0.05 would be, I'm confused here. Hold on.
Would be rejected.
Yeah, if it's below 0.05, then we would reject the null hypothesis. If it's above it, we wouldn't reject it, but kind of like question 18, it needs to be a higher number in order to say that it's completely equal. You know, because you'd have a probability there. So
I'm listening to everything.
I'm just kind of walking through this. So, you know, so basically P equals alpha at this point, right? On question 21.
Can't hear you, Jared. It's really slow.
Oh, Kayla's on.
Yes, I am.
Hi.
Hello.
Jared, you might want to try pausing your video. We're just having a hard time hearing you. Hey man, can I call you back later?
You know what? We'll talk about this later. I gotta go, guys. So
sorry, man. We're meeting. Call you back in like 5 or 10 minutes.
Okay. So
bye.
I gotta take my daughter to class. So
all right.
So I'll be back, and changing that 18. Jared, did you resubmit?
You'd like 2 bites.
Yes, I've submitted it. It's the
insufficient evidence. Yes.
I'm sorry, it's been a long.
Okay. Yes, it has. I'll see you guys Monday. Okay.
Okay.
Yeah.
Bye.
All right.
On here for a while, or? Yeah, Kayla's here. Kayla, what did you need help with?
I actually was pretty okay on this one.
Oh, okay.
Yeah, so I just hopped on for the tail, and I'm so sorry. It was a crazy day. I got here and got all set up, and then I realized I forgot some stuff that I needed at work, and so I had to run back and grab it.
Oh, wow.
It did not go as quickly as possible, or quickly as I expected, so I'm sorry that I was so late. But if you guys are done, I am good with this quiz. I already went through and took it, and I did great. So.
All right. So I just had to run through it the second time because I got one of them wrong. If someone doesn't mind just running through the answers with me, I'll tell you what I have, and you can just tell me to stop when I'm wrong. Is that cool?
Okay.
Yeah.
Okay. So starting at number 3, I have the null hypothesis. Number 4, null hypothesis. Number 5 is not equal to 10. Number 6, less than 10. 7, greater than 10. 8, greater than alpha. 9, less than alpha. 10 is greater than 1500. 11 is equal to 1500. 12 is it is a good assumption. Sample size is large. 13 is central limit theorem. 14 is z. 15 is negative 0.9. 16 is 0.184. 17 is fail to reject. 18 is insufficient evidence that the population mean is less than 150. 19 is type 1. 20 is the probability of a type 2 error will increase, and 21 is 0.05.
Yes.
Okay.
Yep.
Sorry, no, that's a little fast. I got to jump off in just a couple minutes. So.
No, you're good.
Sweet.
Kayla, how did the test go for you?
It went all right. It could have gone better, but it wasn't too bad. So I think I'll just study up a little bit more next time. I didn't have a lot of time this past week to study, and so I think I could have done better, but it wasn't horrible.
I just took my page of notes with me and had everything written on it. in very small words.
All right.
All right, guys, I'm going to stop the recording. I'm starting to have issues right now, so we don't lose it.
Okay.
Okay.
Sorry.
Do we need to run over any? Or sorry, do we need to go over